Hello there guys, in this video I'm going to talk you through some of the principles on direct proportion that you will have seen during your period of home study when the school was closed last year. So I'm going to go through a few examples and things that you might need to remember, so you need to remind yourself, and then we'll have a look at a few questions together as well. Before we start, I'm going to suggest you make sure you've got a pen or pencil and also some paper to hand so you can just jot down any notes you need. And for this whole topic, it's completely fine to use a calculator. It can come up in the non-calculator for GCSE sometimes, but it can mainly come up in the calculator. Okay, so if we have a question on direct proportion in the GCSE exam, the things that will alert you to that is phrases like is directly proportional to, but you can also see varies directly with. Okay, the other thing that you might see, or you might have to use yourself more commonly, is this proportionality symbol, which looks a bit like a fish or a bit like an infinity symbol with the last bit cut off. Okay, so these are the three things that if you see an exam, you know you're dealing with direct proportion. A really good real life example of direct proportion is the cost of petrol and the amount of petrol you put in your tank. So if you ever look at a petrol gauge, you know, at the petrol station, the amount of petrol you're putting in and the cost as you put more petrol into your car, both of those numbers will be going up. They won't be going up the same amount as each other, but they'll be going up in proportion to one another. So once you've put 10 litres in your tank, the amount of money that you'll have to pay should be twice as much as the amount you had to pay when you put 5 litres in your tank. So with direct proportion, if one number doubles, the other one does as well. Or if it triples, the other one does. If one of them halves, the other one will halve as well. If we plotted a graph, let's say, of the amount of petrol against the cost, what you would expect to find is a straight line, okay? And that straight line should go through 0, 0, because if you put no petrol in your tank, you shouldn't be having to pay anything at all, okay? So if you have a directly proportional relationship between two variables, two letters, you would expect them to form a straight line graph going through 0, 0, and you can get tested on that at GCSE. Okay. If A is directly proportional to B, then we can say A varies directly with B, and we could also say that A is directly proportional to B. Sorry, I can't write it upside down like this. Okay, using that formula. If A and B are in direct proportion to each other, the values that A and B can take will always hold the same ratio. And we can use that fact in order to help us to complete a table like this one. Okay, you don't need to write this down, but watch carefully because there are going to be a couple of questions like this for you to do in a minute. Let's say we know that A is 6 when B is 10. If A were 12, you might notice we've doubled that value. We would need to double the B value as well. So we'd have 20. And the ratio 6 to 10 is equivalent to the ratio 12 to 20. Okay. If we made B, sorry, let's make that instead, let's make it 40. Okay, this one has doubled. So this one needs to double as well and become 24. Okay. If we wanted to go from 6 to 9, we've had to times by 1.5, or you can think of it as dividing by 2 and then timesing by 3. So we would have to do the same thing to 10. So 10 times 1.5 would get us to 15. Okay. To get us from 9 to 3, we'd have to divide by 3. So we can do the same thing here and get 5. Or you can use the original 6 and 10 value. You can see both numbers have been halved. So to go from one set of values to another, the multiplication or division has to be the same for both of them. And with direct proportion, when one of them is 0, the other one has to be 0 as well. Okay, just like if you thought about buying petrol. If you're buying 0 litres of petrol, you're going to pay £0 for it. Okay, so that's how to fill out a table for direct proportion. You're looking for multiplications and divisions to get you a pattern to go across. Okay, so for these questions, what you need to do is you need to use the fact that the variables are directly proportional and find the missing values of A, B, C, D, and so on. Okay, so here are the solutions. Each time you work through these, you should have been thinking about multiplying relationships. So for example, here, to go from 7 to 3.5, we divide by 2, or times by a half. So we have to do the same thing here. We're dividing by 2. To go from 4 to 8, we're doubling, so we need to double. Here we've got timesing by 3, so we need to times by 3. So for direct proportion, when you multiply one value, the other one also multiplies by the same number. Okay, so now for the tricky one, which is inverse proportion. So for inverse proportion in an exam, you're going to see is inversely proportional to or varies inversely with. So you need to work out for that inverse word, okay, because it means things are more complicated. When things are inversely proportional to each other, we'll say they're proportional to the reciprocal. So for example, if I said A is inversely proportional to B, or C is inversely proportional to D, I could say that C is proportional to 1 over D. Okay, so it's a little bit different. The graph of an inverse proportion relationship also looks different. You will end up with a rectangular hyperbola, which looks like this. Okay, sorry, that's not very well drawn at the end. That is the same shape that you'll see from reciprocal graphs. So there's a link there for you if you're happy with the reciprocal graph shapes. Okay, so you might be asked in a GCSE exam what the shape is. You could be asked to fill in a table for inverse proportion, which I'm going to show you in a moment. And then there are other things which we'll do in a later video as well. So with inverse proportion, when one value multiplies, the other one divides. So looking here, for example, to go from 12 to 6, we're dividing by 2. So the other one needs to multiply by 2. So we need to have a 10 here. Okay, so we've got that one's dividing, this one needs to be multiplying. Okay, so it's like opposites, okay, or inverse. Okay, to go from 5 to 20, we need to times by 4, which means that this one needs to divide by 4. 12 divided by 4 is going to get us 3. Okay, and then from 6 to 60, that's times by 10. So this one is going to divide by 10 and we'll get 1. You could also have thought of it as timesing by 20 and dividing by 20, or timesing by 5 and dividing by 5. It will work from any one to any other one, as long as you remember when one multiplies, the other one divides. Okay. Another really useful thing that you'll notice with inverse proportion is the pairs of numbers will always times to the same thing. So in this case, 10 times 6 is 60, 5 times 12 is 60, 20 times 3 is 60, and 1 times 60 is 60. One more thing I just want to show you. If I make this one 10, I could do that by dividing this by 6, and I'd therefore have to times the other one by 6. You'll notice that this pair has just been flipped over and swapped around. So you can also do that with inverse proportion. Okay, if you notice that one of the values has been swapped over, then the other one will be as well. For example, if I was given that D is 5, without having to work it out, just by looking at this pair, I know that C is 12. Okay, so that's another little thing that you can do to help out with this. Okay, so for these questions, the variables are inversely proportional, which means that when one of them multiplies, the other one needs to divide. You should also find that your pairs always multiply to make the same number within a table. So use that now and see if you can find the letters M through to W. I'm going to give you a couple of minutes on it, so don't worry if you don't quite have time to finish them all. Okay then guys, so here are the solutions for you. So for the first one, we'll notice that to go from 8 to 4, we've divided by 2. So for the other one, we need to times by 2. And you can also see that every single time our pair of values times is to 160. Okay. Okay, so I really hope that seeing those examples and having a go at those few questions have made you a little bit more confident about those parts of the proportionality topic. The next video in this series is going to be on proportionality as well. We're going to be moving on to some more challenging questions on proportionality at that point as well.